Hi, my name is Dmitro, and in this video I would like to show how to set up and use GraphQL Code Generator. It's a tool that helps you generate the TypeScript types for your GraphQL schema, resolvers, queries, and mutations. In this video I'm going to set up the types for TypeScript, but GraphQL Code Generator supports other languages as well, for example Java and Kotlin. We can use this tool to generate the types for both the backend and the frontend. Basically, we can create types for our queries and mutations manually, especially if the app we are working on is very simple. And that's what I did in this example app. This is a Next.js project, and it includes both the frontend and the backend. The backend is powered by the Next.js API routes feature. It's a very simple nodes app. Basically, you can add a node here, and it appears in this list. That's it. Now I would like to explain briefly how I set up the backend of this app. I will open the editor. The GraphQL API is served from the route API GraphQL. Here I'm importing the Apollo server from Apollo server micro package. This is the Apollo server integration that is most suitable for serving GraphQL API over the Next.js API routes feature at the moment. So in this file, I instantiate the Apollo server, providing it with the schema and the context object. We can use the context object to pass different functionality to the resolver functions. In here I pass the nodes object that is used to read and write nodes. And finally I export the function created by the createHandler method, and this function is used by Next.js to handle a request. I imported the schema from this file. And what this file does is the following. It combines the GraphQL type definitions and the resolvers object into a single data structure that can be used by the Apollo server or, if necessary, Apollo client. The actual GraphQL schema is in this file typedefs.ts. Here it is. Here we have a single query called nodes. It returns an array of node objects. The node object is described here. And we've got one mutation called addNode, which accepts one variable called input of type addNodeInput. Here it is. Then we've got the resolvers file. This is where I implemented the query and mutation, which I described in the GraphQL type definitions. Here they are. We've got the nodes query and the addNode mutation. I use the nodes object from the context to get and add nodes. For simplicity, this object stores nodes in memory, so there is no database. The important thing for me to note here is that I have created the types for these resolvers manually. I created this type manually to describe the return type of the nodes function. I've created the type for the addNode mutation arguments. Here's the type of the input object. I'm describing the return type of this function as well here. And I'm using a generic iResolvers type from Apollo server micro package. This type describes the structure of the resolvers object in general, and it can't make sure that the actual resolvers we need are typed properly. We have to do it manually here. So what I would like to do now is to set up the GraphQL Code Generator to be able to generate the types for the backend automatically. So I won't have to spend much time typing the resolvers manually. To get started, let's open the GraphQL Code Generator's website. Here it is. I will go to the documentation page and look for the installation instructions. Here they are. And the first thing we need to do is to install the GraphQL package. This package is used by the code generator to process the GraphQL schema, queries, and mutations. So I will go ahead and add it. I have stopped the next dev server. Okay. Meanwhile, let's continue. What else do we need? And we need the GraphQL Code Gen CLI package. This is the command line interface for GraphQL Code Gen tool. So I will copy it and install it as well. It's installed as a dev dependency. Let's go back to the documentation to see other instructions. So once we have installed the dependencies, we should run this command to configure the code generator for our project. So I'll copy it and paste here. Let's run it. I'll extend the terminal window. Here we go. So the first thing this initialization wizard asks us is what type of the application we are building. And it looks like it's detected that we are building a React app. And this is true, but at the moment I would like to generate the types for the backend. So I will uncheck this option by pressing the spacebar and check backend. Hit enter. Now we should specify the path to our schema. And you can use either the file system path or a URL. I could have used the file system path if I stored the schema as a string in here in a simple GraphQL file, but I'm storing it in a TypeScript file instead. So I will just go ahead and use the URL. So our schema is available at http localhost 3000/API/GraphQL. Now it tells us to pick the plugins that we would like to use to generate the types. GraphQL Code Generator can generate types not only for TypeScript, but also other languages, such as Reason, Java, Kotlin, etc. That's why it has a flexible plugin system that allows us to specify what we would like to generate. And we already have two plugins selected for us by default. The first one, TypeScript, it generates the types for our schema only. And the plugin TypeScript Resolvers generates the types for our resolver functions. So I will just keep these two plugins and hit enter. Then we should specify where we would like to store the types file. And I would like to store it in the generated folder and in the file called GraphQL backend, because these are the backend types. Okay, introspection file. This option tells the generator to generate a file that includes the schema and various data that was used to generate the types. I would like to omit this file because I don't have a use for it at the moment. This script is going to create a config file for the generator, and here we should pick the name for that file. Let's keep the default. It also adds a script to our package.json to run the generator. Let's call this script CodeGen. Okay, we've got the code generator's config here. This file contains the options we have picked in the wizard. Here is our schema path, and the generates option here. We use this option to list the files, the type files we would like to generate. And for each file, we pick the plugins that we would like to use to generate the types. Together with the plugins option, we can also use the config option here to set the options for the plugins. We will use the config option later. If I open the package.json, we will see that the wizard added two dev dependencies. These are the plugins we have chosen, and the script here. Even though it added the plugins as dev dependencies to this file, it did not install these plugins. So we have to run the installation script. I use yarn, so I will run yarn. If you use npm, you run npm install. Okay, installation completed. Let's run the CodeGen script to generate the types. And we've got an error. Failed to load schema from our URL. And this happened because we didn't run the next server that serves this URL here. So I'm gonna run the server using yarn dev command. This starts the Next.js dev server. Okay, now our API route is up. So let's open another terminal window and generate the types here. Okay, the types were generated successfully. We've got a new folder generated and a new file. I'm going to open it. And in here we've got the types based on our schema and the types for the resolvers. They start here, and there are a lot of helper types. And basically what we need is this type. Okay, let's describe the resolvers here using these types. So instead of this generic interface, I'm going to use the resolvers type from the generated file. And from the start, we've got a few problems here. Let's hover over the nodes to check the error. Types of property ID are incompatible. Type number is not assignable to type string. And this happens because in the GraphQL schema, the ID is defined like this, using the ID type. And GraphQL Code Generator uses a string to describe this ID type in TypeScript. We can check it like this. I'll open the GraphQL backend, TS, look for the node type. Here it is. And the ID is described using scalars ID. Here is the scalars type, and the ID is here. So it's a string. But in our code, we use numbers to describe ID here. In the nodes object, we've got ID stored as a number. So there is a mismatch between this GraphQL schema and what we expect in the code. So let's fix it by changing the ID type in GraphQL schema from ID to an integer. This will turn into a number in the types. So let's regenerate the types. Okay, let's check the resolvers, and this error is fixed. Before continuing, I would like to do one thing that I forgot to do with the resolvers type. The resolvers type takes as generic type parameter the type of the context object. So I will pass the context object type here. So TypeScript knows what the context object is here. Okay, let's continue. Add node. Types of property input are incompatible. Type add node input or null or undefined is not assignable to type add node input. Undefined is not assignable to type add node input. So let's check why this happens. I will hover over the input here. It's of type add node input. Okay. We've got args here. What if So now that we use the resolvers type that was generated specifically for our queries and mutations, I can avoid describing the args argument manually. So I'll remove this type from here. And it's described for us by the code generator now. And we've got a problem here. If I hover over it, there is type undefined is not assignable to type add node input. So the input type from the GraphQL schema can be null or undefined. But add node method expects this argument. So it doesn't allow for undefined for node input. And this is where the mismatch occurs. Let's fix this in our GraphQL schema here, where we define the add node mutation. Let's make the add node input variable required by adding the exclamation mark here and regenerate the types. Okay, let's check the resolvers, and the error is fixed because input is now required. It cannot be undefined anymore. Okay, also we can remove this return types here and here, because the code generator described the return types for us. So the code generator's type definitions make sure that we return the right type here and here. Also, let's remove some things that became unnecessary. I'll remove the types I added manually here. I'll remove this import and this one. So our code became much less verbose, and this feels good. So let's continue. I would like to commit the changes. Okay, I've just remembered that I forgot to handle one more issue. If we open the schema file here, we will get an error that the resolvers object from our resolvers file is not compatible with the resolvers object expected by this function. And the same would happen if we tried to pass resolvers directly to the Apollo server. And this happens because the code generator generates the types for the resolvers that are not compatible with the types expected by this function and the Apollo server. And the code generator's team has fixed this problem. So in order to fix it in our project, we should add an option to the CodeGen YAML. an option specifically for the TypeScript Resolvers plugin. So to add an option for the plugins, we use the config object on the same level with the plugins. And let's look for the name of this option. I will open the website. Okay, let's look for the docs for our plugin. So it's plugins TypeScript and then TypeScript Resolvers. And here's this option. So I'll copy it, paste it here and enable it. Okay, let's regenerate the types. Okay, let's open the schema and we can see that our resolvers type is compatible with the type expected by this function, and it will be also compatible with the Apollo server. Okay, let's add this to the previous commit. I will use the amend option. Here we are. Okay. Now let's set up the code generator for the front end. But first I would like to talk briefly about how our front end looks like. We have a single page, the home page here in the index file. On this page, we run a query to fetch the nodes. Here they are, and we render them in a list. I created the types to describe the query manually. I created the nodes query type. This type describes the result of the nodes query. It's the nodes array, and the type for the node. We pass the nodes query as a generic type parameter to useQuery, so TypeScript knows how the data property looks like, and it's nodes query here. Further, we extract the nodes from data and render them. So it's quite a lot of manual work. Also, we have the add node form here. It's stored in the components folder here. In the form, we generate the add node mutation function using the use mutation hook. And we use this mutation function when the user submits the form to create a node with the user's content. I didn't create the types for this query, so the type of the add node mutation is quite generic. And this means, for example, that the variables are not typed and we can pass anything we want here. So instead of expected input object, we could pass something like this, for example, hello world. And this would work without an error. On the compiler side, of course, in the runtime, we will have a big problem. So let's get it back to the original variables and let's go ahead and generate the types for our front end to make our code more type safe. First of all, I would like to store all the queries and mutations for the front end in a folder called GraphQL. I'll create this folder in the project's root. And inside of this folder, let's store all the queries and mutations in files with the GraphQL extension. For example, for the nodes query, we can create a file called nodes.graphql. Let's move the nodes query in it. Here, I'll copy it from the home page. Right. Now we should configure the code generator such that it looks into this folder, finds all the queries and mutations here, and generates the types for them. So I'll open the CodeGen YAML, and this time I will configure the code generator manually. Under the generates option, let's add another types file that we would like to get generated. Let's call it this time GraphQL frontend. Here we should specify the plugins we would like to use for type generation. And the first plugin is TypeScript to generate the basic types based on our schema. Then the other two plugins are different. The first one is called TypeScript Operations. This plugin generates the types for our queries and mutations. Basically, it generates the types for the query and mutation results, the query and mutation variables, etc. And we need another plugin that generates custom React hooks for our queries and mutations. It's called TypeScript React Apollo. Now we should install these plugins. To be able to install them, we should figure out their names, the names of their packages. And there is a table with the names in the documentation. Here, if I click all plugins in the menu, there is a table. Let's look for the TypeScript operations, and here is the corresponding package name. I will copy and paste it. We should install these plugins as dev dependencies. And let's get the second package name. And here it is, TypeScript React Apollo. All right, I'll hit enter. Okay, the plugins have been installed. Now let's finish configuring the code generator. We need to tell it where to look for the queries and mutations. And for this, we can use the documents option. Here, let's specify the path to our GraphQL files relative to the project root. We would like to look for the files in any subfolder, any file name with GraphQL extension. Okay, let's generate the types. Okay, the types have been generated. Let's check them out. Here we've got some basic types generated from our GraphQL schema. Then we've got the types for our nodes query. Here's the type for the nodes query result data. We've got the nodes query document that we can use to run this query. And we've got the types generated by TypeScript React Apollo plugin. So here are some types, and here are our custom React hooks. So basically these are just functions that wrap the original Apollo use query React hooks with the necessary types set up for us. So let's use this hook to fetch nodes on the homepage instead of this query. Okay, and that's it. That's all we need to run the nodes query now. We don't need the document anymore. We don't need these types anymore as well. No, this import is not needed as well. Okay, so our homepage code became much more simple. Now let's generate the types for the add node mutation. Here in the form, add node form, I'll copy the mutation here and paste it into a file in the GraphQL folder. Let's call this file add node. Okay, here it is. Let's generate the types. All right. Now I'll go back to the form, and we don't need this query document anymore because it's generated for us. Okay. Instead of using the use mutation, we can use our custom hook, use add node mutation. Okay. And now our add node mutation function is properly typed. If we, for example, try to change the variables here to something that is not expected, like for example, hello world, we'll get an error. So the variables should match the right structure, like the input object with the content property. Okay, let's test if our app still works. I'll reload the page and try to add something. Okay, looks like it's working. So that's it. We have used GraphQL Code Generator to generate the types for our backend and frontend. I hope you found this video useful. If you liked it, please hit the like button. Thanks for watching this video and see you next time.